Imagine a place in the universe where the very laws of physics cease to exist. A place where gravity is so overwhelmingly powerful that nothing, not even light, the fastest thing in the cosmos, can escape its grasp. Welcome to the world of black holes, the most mysterious, terrifying, and fascinating monsters in the fabric of space-time. For decades, they were thought to be science fiction, but today, we know they are real, and they are reshaping everything we know about reality. To understand a black hole, we must first look at how one is born. It all begins with a massive star, one that is at least 10 to 20 times larger than our Sun. For millions of years, this star fights a constant, epic battle between its own cosmic gravity pulling inward and the outward pressure generated by nuclear fusion at its core. But eventually, the star runs out of fuel. With no outward pressure to fight back, gravity wins instantly. The star collapses under its own massive weight in a matter of seconds, triggering a cosmic explosion known as a supernova. This blast ejects the star's outer layers into deep space, while what remains of the core collapses into an infinitely small point with unimaginable density, and a black hole is born. A black hole isn't just an empty void of nothingness, it has a very specific, invisible anatomy. First, there is the accretion disk, a swirling, glowing whirlpool of superheated gas, dust, and ripped-up stars spinning around the center at near light speed. The friction in this disk generates so much energy that it shines brighter than entire galaxies. Then, we encounter the event horizon. Think of this as the absolute point of no return, the physical boundary of the black hole. Once any object, planet, or even a single photon of light crosses this border, the escape velocity required to get out becomes greater than the speed of light. Because nothing can travel faster than light, nothing can ever escape. And at the absolute center lies the singularity. Here, all the matter of the collapsed star is crushed into a space of zero volume. At this precise point, density and gravity become infinite, space and time swap roles, and our current understanding of physics completely breaks down. It's the ultimate sci-fi question. What happens if you fall into a black hole? Well, your journey would depend entirely on who is watching. If you were falling into a smaller, stellar mass black hole, you would experience a brutal physical phenomenon known as spaghettification. Because gravity increases exponentially the closer you get, the pull on your feet would be thousands of times stronger than the pull on your head. Your body would be violently stretched and elongated into a long, thin string of atoms before you even touch the event horizon. Interestingly, to an outside observer watching you from safety, you would never actually be seen falling inside. Because extreme gravity warps time itself, they would see you slow down as you approach the edge, turn a deep dark red, freeze at the boundary like a ghost, and slowly fade away into the darkness. To them, time for you has frozen. To you, the universe behind you would speed up dramatically, allowing you to watch the entire future history of the cosmos flash before your eyes in an instant. Not all black holes are created equal. They come in wildly different sizes scattered across the dark. The most common are stellar black holes, which are just a few times the mass of our Sun, but packed into a space the size of a city. Then there are intermediate black holes, the missing links of cosmic evolution. But the true kings of the cosmos are supermassive black holes. Found at the dead center of almost every major galaxy, including our own Milky Way, these giants can weigh millions or even billions of times more than our Sun. Our local monster, Sagittarius A star, sits 26,000 light-years away, silently anchoring our galaxy. But despite their terrifying reputation as cosmic garbage disposals, black holes aren't just destructive vacuum cleaners. They act as the ultimate anchors of the universe, holding entire galaxies together, controlling the speed of star formation and playing a vital, creative role in the birth of solar systems and the evolution of the cosmos itself. Black holes remain the ultimate gateway to the universe's greatest secrets, standing at the tense boundary where quantum mechanics meets gravity. They remind us of how much we have yet to learn about the vast, beautiful dark above us, challenging the limits of human intellect. If you enjoyed this cosmic journey into the deep unknown, don't forget to hit the like button, subscribe for more space exploration, and leave a comment below. If you could safely look inside a black hole, would you do it? Until next time, keep looking at the stars.